Today we're going to be looking at quadratic functions. So I want to remind y'all of what a function is.
And piecewise functions.
And we're going to be looking at piecewise functions too. And I want to remind you of what we said the last time, that a function's a rule that assigns to each x value exactly one y value. The set of all x values is called the domain, and the set of all y values is called the range. And if it's a function, then the graph should pass that vertical line test. We're only graphing functions today, so that means everything we graph should pass the vertical line test.
I think it's true to say we're going to be graphing functions the rest of the semester. Am I right?
Yes. But that's all we're going to graph, but that's not all we're going to do.
Yeah.
I think what you're trying to say, the only thing we're going to graph from now on is functions.
Yes,
okay.
That's what I said.
But we'll be doing a lot more than graphing. But we're going to, for quadratic functions, remember back weeks ago when we were first introducing the graphing tools, we said that there were U-shaped figures and called a parabola. Here's one of those U-shaped figures that's opening, that's on the side. Notice it fails the vertical line test. So the only type of quadratic functions, the only type of parabolas we're going to be graphing are the ones that open up and down, because they're all past the vertical line test. So coming over here,
the little functions written as equations, the way you take the number in the parentheses and plug it in for x.
Oh, they remember that.
Remember
that function notation that says take the number that's in the parentheses, plug it in for x. The number you get is the y coordinate. The number in the parentheses is the x value. The corresponding y value is the number you get when you plug the x in.
And you can only have one of those y's. You can't have two or three.
For each individual x.
And that's going to be significant with the first problem you're doing. So let's start piecewise.
No, there's one other thing I want to mention right now. When we're finding domains, we're finding domains of functions. Remember I said the last time, if your function has no square root and no fractions, then no fractions, no square roots, what do you assume the domain is? All real numbers. This is a quadratic function, this thing we wrote here. Notice x squared minus 13x minus 7. Quadratic means the biggest exponent you have is 2. This is quadratic, so the domain is all real numbers. Any quadratic function will always have the same domain, because it won't have any square roots with variables under it. It won't have denominators that could equal 0. And so that's going to be significant later on when they're asking us for the domain of quadratic functions. Now, moving on. We're looking at two different types of functions in this assignment, piecewise and quadratic. We'll start with piecewise.
I like the way you spelled piecewise correctly. While he's writing out, I'm going to mention I before E except after C, or when sounded like A as in neighbor and way, but either, neither, forfeit, seizure, or weird. Those are
That's the rule, right? Okay, a piecewise function, loosely speaking, is just a function that's defined using more than one piece. And more than one algebraic expression, I could say.
May as well show them.
And to explain it, really, you have to look at one. So let's look at number 2. So you can see what we mean by a piecewise function. Some people call them piecewise defined functions, but over the years, people have dropped off the word defined. So this is number 2.
This is a function. Notice it's using h instead of f. No reason it has to use an f for function. H is perfectly fine. But notice how the rule is broken up into 3 pieces. That's why it's called a piecewise function. And I think
I'm writing it down.
In different color for each piece.
Each piece I'll write in a different color. That'll be especially important for me when I'm graphing these piecewise functions. And x plus 7 x plus 7. This college rule paper is not really made for someone that writes big like I do. I suppose that large writing is a result of my multiple penmanship awards. 2nd, 3rd, 4th, and 5th grade. Nettie Marshall. I was the penmanship champion. And now what's cursive writing used for now? Nothing. So I remember when I discovered my students couldn't read my cursive writing on the board.
And that's when I said stop the cursive.
Mm-hmm. Okay. There are 3 different pieces here. Let's switch over to my...
Did you want to write what your first thing is?
Oh, I guess you're right.
Find h of negative 10.
I just want to analyze the function a little before we start evaluating it. A piecewise function has multiple pieces, and you can't plug in the number into every piece, because remember, for any x, there can only be one y. We can't have 3 different numbers as the value of the function here. You can only plug in that number into one distinct piece. So to decide which piece you're going to use, realize this number here is your x value, that negative 10. Which piece is satisfied? By that I mean which inequality is satisfied. Is my negative 10 less than negative 8? Or is negative 10 right between negative 8 and 5? Or is negative 10 greater than 5? Which one is satisfied? There's only one of them. The x value can only satisfy one piece. The red piece, the purple piece, or the green piece. Which one?
Negative 10 less than negative 8?
Is negative 10. Notice this compound inequality here. That's saying that the x value is between negative 8 and positive 5. Or is negative 10 bigger than 5? Which inequality is satisfied? Okay, so negative 10 is less than negative 8. So you plug it in here. Negative 5 times negative 10 minus 17. Well, negative 5 times negative 10, that's 50. Minus 17 gives me a y value of 33. Now, if you had plugged in negative 10 down into the green piece, negative 10 plus 7 is negative 3. But that can't be right, because for any x, there can only be one y value. So let's punch in 33. We're doing 2 things with piecewise functions. We're evaluating them and we're graphing them. The first thing we're doing here is just evaluating. Using
By evaluate, you mean
plugging in. But you got to figure out which piece to plug into. Okay. H of negative 3.
H of negative 3. Is negative 3 less than negative 8?
Is it between negative 8 and positive 5? Or is negative 3 bigger than 5?
Which rule are we going to use? The red, purple, or green? The x value is...
negative 3. Which inequality is satisfied? The purple, I agree. Negative 3 is between negative 8 and positive 5. So we come over to the purple piece. Wait a minute, there's not an x to plug into. So the y value is just 5. That piece is a constant piece. For every x value between negative 8 and positive 5, the y value is just 5. Okay, h of 5.
Notice every x can have only one y. You can't plug into all three of these. You can't have a red answer, purple, and green answer. Just one number.
For the one x value of 5, which condition is satisfied? Is 5 less than -8? No. Hey, I see a 5 here in the inequality. Is equality allowed here? Can x equal 5 on the purple piece? No, it's just got to be less than. Which piece allows equality? That green piece. Greater than or equal to. So for h of 5, you have to use the green piece. That'll become a plug in the 5 into the green piece to get 5 plus 7, which gives me a y value of 12. And I should have boxed that answer or circled that answer and that one. To evaluate a piecewise function, you have to decide which piece is satisfied, which inequality is satisfied by the given x value. And
h of 9.
There's another one, h of 9. 9. Is 9 smaller than -8? Is 9 between -8 and +5? Or is 9 bigger than 5? Bigger than 5, so that's a 9 plus 7, which equals 16.
Tim, you wrote that 16 in green.
Yeah, you're right.
Let's make up one. How about...
I'm going to, but touch in that 16.
Yeah, they'll feel more confident when they know you got it right.
I'll be confident in my abilities, right?
That.
Okay, I'm going to make them. It seems, I don't know why they have to start at the first one and work their way through. So you're going to have to tell me, how about, I'm going to make up some more. How about h of
0?
0. Good. Which piece are we going to use? Red, purple, or green? Is 0 smaller than -8?
By that you mean -9, -10, -11, the things to the left of -8 on the number line.
Is 0 between -8 and +5? Or is 0 bigger than 5? I heard you say yes, so it's between -8 and +5. So we come over here, it's that constant piece. There's no variable to plug in. The y value is just a 5. What about h of
-100?
Okay. H of -100. Is -100 smaller than -8? Is it between -8 and +5? Or is it bigger than +5? It's smaller than -8, so we plug it into the red piece. That's a -5 times a -100 minus 17. -5 times a -100 is a +500 minus 17. Is that a 483? So you tell me the x value, and I'll figure out which piece to plug it into. Any questions on our logic there? To evaluate a piecewise function, all you do is you figure out which piece is satisfied, which inequality is satisfied by the x value, and that's the piece you use. But you can't use more than one piece for any given x value. Any questions there?
Let's do one more. Do h of 5.0001.
Okay, I like that. I see where you're going with this, Tony. H of 5.0001. Which piece would be satisfied? Is 5.0001 less than -8? Is it between -8 and +5? Or is it bigger than +5? It's bigger than +5. So we have to use the green piece. That's a 5.0001 plus 7. That gives us a 12.0001. That's going to be significant.
Now let's do H of 4.9999.
Okay. H of 4.9999. Which piece is satisfied? Is 4.9999 less than negative 8? Is it between negative 8 and positive 5? Or is it bigger than positive 5? Okay, to the naked eye, if you were looking at a number line, 4.9999 would look like you were at 5. Okay, so you have to use this piece here, and the y value is 5. If I told you to go up here, here's the ordered pair, 4.9999, comma 5. And I said label it on an XY grid. To the naked eye, it would look like the ordered pair 5, 5, wouldn't it? 4.9999 looks like the number 5 on the x-axis. And so you get that ordered pair 5, 5, and that's going to be significant for what we're about to do. Any questions over evaluating? You figure out which inequality is satisfied, that's the piece you use. Okay, graphing piecewise functions.
Number 6. Oh, good. I like the way you can't see the multiple choice there.
Okay.
I wondered why they did that. You know,
Oh,
they don't
please
used to
don't
let
tell
you
me.
change that.
Yeah,
Now,
I told you about that.
Oh, okay. What about
Last year, I don't know.
problem 6, and you're going to use 3 colors, right?
There are 3. We want to graph the piecewise defined function. So here they're calling it piecewise defined, not just piecewise. So f of x equals. I don't like that green. Let's see if this is better. Okay, we're going to use the piece 2 plus 2x if our x value is less than negative 4. We're going to use the piece negative 2x to find the y values if the x values we're using are between negative 4 and positive 5, including both of the endpoints. And we're going to use just the piece positive 2x if x is greater than 5. Let me make sure I didn't miscopy this. 2 plus 2x if x is less than negative 4. Okay. Okay, switch over. The most basic form of graphing is just plotting points. That's the most basic form of graphing. You're just plotting points. And that's what we're going to do to graph these, but we're going to plot points intelligently. We're not just going to start randomly choosing x values to plug in to create the ordered pairs. There are 3 different pieces, so I'm going to make 3 different tables of values. I'm going to make my purple piece using purple ink. I'll make the blue piece using blue ink, and I'll make the red piece using the red ink. You're just using one color, so my advice to you, number the pieces. This will be piece 1, the middle piece is piece 2, and the bottom piece is piece 3. So here's table 1. I'm going to make it XY grid. For lack of a better word, now realize that negative 4 is where the purple piece cuts off and switches to the blue piece. At positive 5, the blue piece cuts off and switches to the red piece. And so for lack of a better word, I'm going to call these Points where the graph is changing, cut points. So we're going to have a cut point at -4 and at +5. When you're making your table of values, the first number or numbers you must use are the points or the cut points themselves. So you're going to have to plug in this -4 as your starting value.
But wait a minute, it doesn't say that you could have x equal -4.
But it could be something like this thing right here. 4.9999. It looks like 5. It looks like 5. And
so when you're plugging in 4, you're really plugging in 3 on the one you're going to do.
But I'm plugging in this -4. I'm really plugging in -4.00001. Numbers like that. But you have to remember, whatever number appears within the interval, that's what you must start with. And to label these cut points, you're going to use the same rule you use for solution cut points. For solution cut points, if there's no equality, how do you label the thing? With an open or closed circle? Open circle. Now y equals 2 plus 2x. Y equals -2x. Y equals 2x. All three of these pieces are, well, you tell me. If I were to graph y equals 2x plus 2, what sort of a figure would I get? I think it's the first thing we graphed in this course. No exponents, no absolute values. What sort of a figure are we expecting to get for y equals 2 plus 2x?
Starts with the L.
If it were an x squared, we know it would be a quadratic. But
it'd be a parabola then.
If it's just an x, what will the graph be?
L.
Linear.
Line, yeah.
Y equals mx plus b. It's a line. These things are lines.
How many points do you need for a line?
2 points.
Okay.
You already have the first x value. You have to plug in -4. Now you need to choose an x value that's actually less than -4. Choose a number that satisfies the inequality. Could I use 0? I always like to use 0. Can I use 0? Is 0 less than -4? No. Maybe -5. Choose a number that's close to -4, but make sure it satisfies the inequality. I could use -5. I could use -6. I think I'm going to use -6 so that it's a little more spread apart. Okay. I think I'll use -6. Now, is -6 a cut point? Did we see -6 here in the inequalities? No. The numbers you choose yourself are just plain dots, the way you make a dot to draw a line. The only time you can have an open circle is when you're plugging in a cut point and there's no equality. Like down here in the red part, I'm going to have to plug in 5 in a little bit. There's no equality, so it's going to be another open dot. But when I plug in -4 and +5 into the blue piece, are those dots going to be open? No, because there's equality there. Take the -4, plug it into that purple piece. Okay, you're going to have a 2 plus 2 times -4. What's that going to give us? That's a 2. Positive 2 times a -4 is a -8. 2 minus 8 gives me a y value of
-6. They're just not total. Oh, Tim. And you just realize that -6 here has nothing to do with this
-6. I just wanted something a little bit further away from -4, but it's just a coincidence that those numbers are equal. Plug in -6. We're going to get a 2 plus 2 times -6. That's a 2 minus 12. 2 minus 12 is -10. I'm going to draw myself an XY grid. I'm trying to see. It looks like I'm going to need a lot of room there, aren't I?
Yeah.
You know something? I'm going to come over here and draw the graph.
Oh, okay. I was going to say, maybe you should draw it here. You don't normally use front and back.
I know, but I could. That's a good idea. Okay, so I'm drawing my XY grid. Oh, and by the way, we didn't comment, but this is a piecewise functions. There's not a graphing tool built into this class, so these numbers are going to be
These graphs
are
are
going to multiple choice. Okay, and the first point I'm going to label is at -4, -6. 1, 2, 3. You know something? It's a good idea. What were the cut points? He said they were -4 and +5. Label those numbers very clearly on the x-axis, because that's where the pieces are going to change. 1, 2, 3. There's -4. 2, 3. Here's +5. So at -4, the purple piece will change to the blue piece, and at +5, the blue piece is going to change to the red piece.
This is some nice graph theory. Over here to the left, you're going to have the purple piece.
Okay.
Between -4 and 5, that's going to be the blue graph. To the right of 5, that'll be the red one. So go ahead and...
-4, -6, 1, 2, 3, 4, 5, 6, and we put an open circle. Now for -6, -10, any number that you choose yourself. I didn't choose that -4 myself. I had to use it because it was a cut point. But the numbers you choose on your own must satisfy the inequality, so they've got to be regular closed dots. So -6, -10. There's -6, left 6, down 10.
Ooh, lift it up a little.
There. You start at the cut point. You start at the cut point and you draw. The interval started at -4 and it goes to the left. Does that interval ever stop? It started here, it goes to the left. Does it stop? No, so the left side of the graph doesn't stop. It started at the cut point, it goes to the next point, and it keeps going forever. Any questions on our logic there?
Do not put an arrow where the open circle is.
If you put an arrow here, that means you think this interval keeps going past -4.
It does.
You can. It's safe to say you're not going to have arrows at cut points. Now the blue piece. The blue piece, this is table 2. We said it's another line. I like this blue piece because there's no free will. I don't have to make a decision. I know what 2x values I'm going to use. I have to use the 2 that are with the inequality. So I have to plug in a -4. I have to plug in a +5. Are those cut points going to be open?
Or closed?
They're going to be closed because there's the equality. So they're just regular closed dots. Plug -4 into the blue piece. -2 times -4 gives me what for my y value? +8. I agree. Take the +5. Plug it into the blue piece. -2 times 5 gives me a -10. So I go to my graph. I locate -4, +8. -4, I go up 8 units right there. And then I go right 5, down 10. I go right 5, down 10.
He's going to connect the two dots. Will he put arrows on them?
I'm connecting them.
Are there going to be arrows on this? No.
Okay, no, because it starts at -4, it stops at +5. Notice this interval. It doesn't keep going and going forever. If you wrote an interval notation, there wouldn't be an infinity or a negative infinity. And so it started here, it ended here. The blue graph is just a line segment, nothing else. Last piece, the red piece. What's the first number I'm
plug in?
There's only one correct number to plug in first. What must I plug in to the red piece? 5.
Will there be an open or closed circle at the 5?
Because
Open.
there's no equality. I agree. Now choose an x value that's bigger than 5. I'll use 6. Because if I use 7, I'm getting up 14 units. That's getting mighty far off. Take the 5, plug it into the red piece. What am I going to get? I couldn't hear you. +10, I agree. Take 6, plug it in. +12. And let me ask you something. Why did I use 6 here? Why did I use 4? Could I have used 4? No, I have to use an x value that's bigger than 5.
Because you want that graph, the red graph is to the right of 5.
Hey, this point that I made up myself, I chose that 6 on my own. Is that going to be an open circle also? Is 612 a cut point? No, it isn't. Any x value, any point that you make by you choosing the x value yourself is automatically a regular closed dot. So we locate 5, 10, right 5, up 10, open circle. Then I go right 6, up 12.
Wow. This is some good graphing. If you understand or can follow what we're doing here, you know a lot about graphing.
I agree. Okay, we start at the cut point. We go to the right. Is it like this one here where it just stops? Am I just going to stop there? Or does it? No. The interval starts at 5 and keeps going, so the graph keeps going.
Now, with the multiple choice, you can usually
As soon as you get one piece drawn,
you can almost figure out
you
which
can figure
one it
out
is.
which one.
Now, a
it is.
word of warning. Sometimes students get upset because the graph answers, they're going to show the open and closed circles. They don't just show the dots, the numbers you're going to choose.
Because anyone could, I mean, they
You could have
use
chosen a different number.
And so the only points they're showing on the graph are the cut points themselves.
Now, I'm going to do this. And let me see. I'll start blowing them up. Let's see. Is that it?
Clearly not.
Okay.
How about part B? Oh, that might be it.
Oh.
I think that's it.
Well, let's knock out the others. Can y'all see? That's an open circle there.
And the line segment
Close,
in the middle has
close.
close, yeah.
Well, let's make sure that there's not two that are. No, it's
No.
not C. Is it D? No. Which one was it?
B.
B. They'll probably be sitting there wishing for some little graphing tools. I keep thinking
Don't
one
worry,
day,
we're going to have a real nice graphing tool in a moment when we start.
but just for parabolas. They want a piecewise graphing tool.
Oh, goodness.
No. Okay. Any questions on that? If you can follow what we did here with that one, then you know how to graph a piecewise function. You understand a lot about graph theory. Okay?
Okay.
This one had 3 pieces.
Most of them just have 2 pieces. Let's look at number 3.
Okay, let's do one that's going to might seem a little easier now, as there's only 2 pieces on this one.
Let me write it down. This is number 3. F of x is equal to, we'll use the piece x minus 1 if x is less than or equal to 2. And we'll use the piece 1 if x is greater than 2.
Number 6 is the only one that has 3 pieces for you to graph. The other ones are just going to be like this, only 2 pieces.
But the 3 piece is my favorite.
I know, because if you understand how to do that 3-piece, the 2 pieces are easy, and you know a lot about graphing.
Let me ask you this. Here on number 6, we had 2 different cut points. We had -4 and we had +5. Are we going to have 2 different cut points in this number 3? What's the only number that's acting like a cut point? Where will the blue piece change to the red piece? It should be obvious. 2. The only number that appears within the inequalities is 2. So we're going to have 2 pieces, piece 1 and piece 2. Make my table. What is the first number I must plug in for x in the blue piece to get my starting point? What's the first number I have to plug in? I couldn't hear you. 2. I have to plug in 2. It's a cut point.
Open or closed circle?
Closed circle, because there's equality there. Now, I need another x value. Can I use 3? I need a number smaller than 2. Can I use 3? I could use -3, -2. I could use 0. Heck, I'm going to use 0.
Use 1, 0,
but I can't use positive.
-2, -3. Can't use +3. Can't use +4. It has to be a number smaller than 2.
And you made that number up yourself. You decided on that number, so it's just a regular closed dot, okay? Plugging 2 into the blue piece. 2 minus 1 gives me a y value of 1. Plugging in 0. 0 minus 1, we get a y value of -1. So I'm making this graph is going to fit right down here. So I'll draw my XY grid. Make my little tick marks. We're starting at the point 2, 1. 2, 1. Right 2, up 1. Right 2, up 1. And then I'm at 0, -1. Left, right, 0, down 1. 2, 1 is the starting point. It starts there. It goes here. Does it stop? It just stops. It's just this interval ends. X less than 2, that interval ends? No, it doesn't. You're going to have an arrowhead on your graph. You'll start at the cut point and go in the direction of your secondary point. The only way you won't have an arrowhead on the graph is if it's a compound inequality, like this piece here. It started at -4, it stopped at 5.
Also, on the left and right extremes, that's where you have the arrows.
Okay,
Right,
this is the left side.
See, like over here, the right side.
The right extreme had an arrow going to the right. The left side, the left extreme, had an arrow there on the left.
You wouldn't have an arrow out here, or else it's not going to pass that vertical line test.
If it went like that, fails the vertical line test, not a function. And we know these are functions because they're called piecewise functions.
The f of x is telling you it's a function.
Okay, now the red piece. This is table 2. What's the first number I must plug in for x?
Will it be an open circle or a closed?
Okay, I got to use 2. That's my cut point. Is it going to be an open or closed? Open. Now I need an x value that's bigger than 2. Can I use 0? No. Here I can use what? 3?
4, 5.
I could use 50 if I wanted to, but use something that's easy to label on the x-axis. Is this secondary point that I'm making up myself, is that going to be an open circle also? Any number you're choosing on your own must be. You can't choose a number that doesn't satisfy the inequality. We're using an open circle here because 2 isn't greater than 2. It's equal. 2 doesn't satisfy that condition, but 3 does. The numbers you choose must satisfy the inequality, therefore they're plain closed dots. Oh, this is nice. What's the y value going to be for both of these? 1 and 1.
It's called a constant function. It never changes.
On the right-hand side.
The red piece
piece
is a constant function.
I go to the point 2, 1 to put my open circle, and to my shock and horror, what's sitting there? Closed circle. Closed circles take precedence. An open circle says, oh, this point isn't on the graph, but 2, 1 is on the graph. It's on the graph because of the blue piece. So if you have an open and a closed circle at the same space, closed circles take precedence.
But since you're using different colors, you can put the little red open circle around it.
But the multiple choice option isn't going to do that. So.
Oh, and you didn't ask him about.
Oh,
the
I
arrow.
forgot to ask you. The arrow? The arrows are on the extremes, the left side and the right side. The only way you don't have an arrow is if your inequality has a starting and stopping point, like that compound inequality right there. And that's only going to happen when you have a 3-piece function. If you have an open and closed circle appearing at the same spot, the graph has a regular closed dot.
Let's look at these answer choices. Let me move this up. Let's see. Oh, let's look at B first.
Is that it? No, that's not it. I think you can just look and tell, just a casual glance.
I know.
It's going to have to be what?
Is it A?
I think it's going to be A, isn't it?
And notice, just a dot there. If an open and closed circle occur at the same point, make it closed. Okay.
Closed circles take precedence.
Okay. Oh, it's already lit up. A. Did I do?
Yeah, you did.
Oh, okay.
No, the computer did that. Computers do things like that.
Okay. You want to say maybe?
Yeah, let's do number 5. Let's do one more piecewise graph.
Just to make sure y'all get the hang of these constant functions. We have two constant pieces on this one.
We normally do number 4, but we have videos of us working the number 4s. I don't think I've ever worked this number 5 in one of the lecture videos, so I thought let's do that. F of x equals -2 if your x value is less than or equal to 1, and it's a -1. I think I'll use blue. -1 red. Can y'all read? Is there anyone that has trouble reading red?
If so, just tell
That
me.
is a very common.
Colors.
That's a very common vision problem. Reading oranges and reds. I'll confess, as I've gotten older, I have that problem when it's not on white paper. I'm fine on white paper, but if it's on colored paper, forget it. I'm not going to be able to see it.
But ever since my eyes did that bizarre thing and improved, I don't have much. I mean, my vision is better now than it was 2 years ago. And I haven't had any surgery or anything.
You're just jealous of my toric lens implants that I had, correcting my astigmatism. So, well.
Okay.
What's the cut point? What number will the purple piece change to the red piece? At the number 1. I agree. So we're going to make 2 tables. This is table 1 and table 2. Table 1, this is the purple piece. What's the first number I must use for x? I don't have a choice. 1, that's the cut point. Is it going to be open or closed? Closed, I agree. Now we need an x value smaller than 1. What do you want to use? 0 is a good one. In both cases, the y value, there's no x to plug in. The y value is going to be -2. So I'm drawing my xy grid. I sure like just drawing the graphs on the program rather than doing it on paper. Just they look so much better.
Oh, here it's multiple. I guess I could get the points and then look at the graph.
To see which graph contains those points.
Mm-hmm.
Yeah. So at 1, we go right 1. I want to make sure 1 is clearly labeled. There it is. We go right 1, down 2, close dot, left, right 0, down 2. Here's the cut point. It starts at the cut point. Is the graph going to stop? No. This half a line that we're drawing is called a ray. You may remember that if you've taken geometry somewhere or another. So it's a closed ray because the starting point is a closed dot. Now we'll make our red table. This is table 2. What's the first number we must plug in for x? We don't have a choice. 1 again. It's a cut point. Is that going to be open or closed? It's got to be open because there's no equality. Now I need an x value bigger than 1. You tell me the number you want to use. 3, okay. You could use 30,000, but use something that's easy to label on your grid. Is this going to be an open circle? And it's going to be a regular closed dot. 3 is not a cut point. The numbers you choose yourself or regular closed dots. In both cases, these y coordinates are going to be what? -1. So we go to right 1, down 1, we have an open circle. That looks like a -3. That's a closed dot, okay? That is not saying a -3. That's a closed dot. We go right 3, down 1. We have a regular closed dot. The graph starts at the cut point. Is it going to stop? No. The interval keeps going and going forever. This is actually a good example to illustrate something that we were trying to make, a point we were trying to make earlier. Why did we use 1? It says x can't equal 1. It has to be greater than 1. Why did we even use 1? The real number system is dense. Between any two real numbers are infinitely many other real numbers. I claim there are infinitely many numbers that to the naked eye would look like 1, but they're actually greater than 1. For example, 1.00000001.
Wouldn't that look like the point 1 negative?
But isn't it greater than 1? Isn't this number bigger than 1? So this point's going to have to be on the graph. The y value is a -1. If I told you, label this ordered pair, to go to your grid and label it, it's going to look like you're labeling 1, -1. That's why we have that open circle there. We're saying 1, -1 isn't on the graph, but there's infinitely many other points that look like 1, -1 that are on the graph. Just like over here, this open circle right here, 5, 10 is not on the graph, but 5.000001 and 10.000002, they are on the graph, but to the naked eye it looks like 5, 10. That's why you had to plug in that 5 over here, even though x can't equal 5. Any questions there?
I can't remember. Did I choose the right answer?
I don't know if you did or didn't.
Oh no, we have not. Let me see.
A, B, C, or D?
Oh gosh, they all look alike on this one.
Is it B? Look at B.
B?
Is it B? No, it's the open and closed dots you got to be careful of. I think it's C. Look at C.
C? Is that it?
Yeah.
Oh, and by the way, on the graph, Tim has labeled 3, -1. Is that it? But notice, the points you choose, those dots aren't labeled on here.
The only points they're showing are the cut points themselves.
With the open and closed circles. So it is that one, C. Oh. When I blow that up?
Does it automatically choose it? I don't know.
Okay.
Oh. I can't.
So that does this assignment. You look at piecewise functions and quadratic. We're about to look at quadratic functions. Y'all already know what quadratic means. It means there's an x squared in it. Okay? A quadratic equation is ax squared plus bx plus c equals 0. A quadratic function is...
You got to switch it for my paper.
Oh, yeah. Sorry.
A quadratic function is any function, instead of ax squared plus bx plus c equals 0, it's the function of x, or the y value, equaling ax squared plus bx plus c. And since we said that the graph is a U-shaped figure called a parabola. God, that seems like a long time ago that we started those graphing tools. But this is the end of the 8th week. We're at mid-semester now. And we're only going to be graphing the functions that are, the parabolas that are functions. That means they're going to either have to open upward or it can open downward. When we looked at the section on graphing tools and graph quadratic, the quadratics the first time, we had a 3-point graphing tool. Here we're only going to have a 2-point graphing tool, similar to the absolute value graphing tool. If a parabola is opening upward, there is a low point at which the graph changes directions. It's falling, it hits that low point, and then it starts to go up. If it's opening downward, it goes up, it hits a high point, and then it starts to fall. The point where the graph changes directions is called the vertex. There's the vertex when the parabola is opening upward. Here's the vertex when the parabola is opening downward. I can just look at the function and I know whether it's going to open upward or downward based on the number in front of x squared. If your a value is positive, then you expect the parabola to open upward. If the a value is negative, you expect the parabola to open downward. These things are symmetric. If you could draw a vertical line passing through the vertex, if you were able to draw a vertical line that passed through the vertex and then folded the paper down that line, the right-hand side should lie directly on top of the left-hand side. Well, with human error, these don't really look symmetric, okay? They don't look like mirror images, but when you're drawing it using the MyLab, you'll be able to tell that symmetry. It'll be very nice. And there's the axis. So this imaginary line is the axis. And they'll be asking you for the equation of the line, the axis. Vertical lines have equations with an x and no y. So we have an axis formula. That axis formula is also the vertex formula. It'll help us determine where the vertex occurs. I'll say the vertex, in parentheses, I'm going to write axis formula.
Y'all have used the quadratic formula so much. Have y'all sort of memorized it at this point? How does it start, the quadratic formula? Negative b.
Okay. X equals negative b. It's the quadratic formula without the messy plus minus square root of b squared minus 4ac. It's just negative b on top. And what's the denominator of the quadratic formula? 2 times a. There it is. Use this formula using a and b, and that'll tell you where the vertex occurs. But it just gives you the x value. Once you know the x value, how do you find the y value? Plug it in to get the y value. So what we're going to do is we'll make to graph these things, we'll determine the vertex, and then we're going to make a table of values. We'll make it XY table. You have to use the number you found here. Negative b over 2a. That'll be the vertex. And I'm going to write out there beside it, vertex. And then, using the new graphing tool, you have to plot the vertex first. And then they ask you, okay, plot another point. So you choose another x value. It's up to you. Usually you need to choose a number that's close to the number you've already found.
For instance, if the negative b over 2a formula turns out to be a 7.
Use 8 or 6. Use a number close to the to the vertex. I'll say another x value.
Just choose any other number.
But usually close to the number you've already found.
It's any other number.
But you'll see we're going to be operating with that graphing tool. Sometimes the little grid will just go 10 up and 10 down. If you plug in a number and you get a y value of 30, you can't plot it then. That's why we say the number you use needs to be close to the vertex. You'll see what I mean when we start using the graphing tool in a moment. And they're going to ask for the domain and range. Well, we know the domain of a quadratic function. The domain of a quadratic function,
there's no fractions.
No fractions, no square roots. What do we assume the domain is?
One of those things you mentioned right at the
beginning. Okay, hold on. I'm going back to the last. Let's see, where is it? We were doing this the last time. Isn't this a quadratic function? Ax squared plus bx plus c. What was the domain? No fractions, no square roots. The domain is all real numbers. So it doesn't matter what the quadratic function is. The domain will always be all real numbers. For the range, you have to look back at the vertex. The vertex is either going to be the lowest point on the graph,
which is a
minimum y value, or the highest point, which corresponds to the maximum y value. If the parabola is opening upward, that y value there at the vertex is the smallest y value on the graph. I'm going to write on there, right here, that's the minimum y value. Whereas this point right here, that's the highest point on the graph. That's the highest point on the graph, so that's the maximum y value.
In a little while, we're going to have some really good applications, word problems,
of quadratic functions, and they're going to be asking you, find the maximum or the minimum value. If you have a maximum or a minimum value of a quadratic function, then those things must occur where? At the vertex. So to find the location of the maximum or the minimum, you're going to use your vertex formula, and then whatever number you get, you'll plug in to get the value of the function.
It's actually going to be some really easy word problems. Don't let them scare you. All you do is minus b over 2a and plug it in.
Because they'll be looking for maximums or minimums. And that's where a maximum or minimum occurs. If it's opening upward, the minimum occurs at the vertex. If it's opening downward, the maximum occurs at the vertex. Now for the range, if a parabola is opening upward, okay, remember we said whether it's opening upward or downward, the domain is all real numbers. But if it's opening upward, the range, that's the y value. The smallest value on the y value on the graph is this right here at the vertex. That's the smallest, and then every number bigger is being used. These y values are getting bigger and bigger. So the first, it'll have a bracket because the number is used. It'll be the y value of the vertex, y value of vertex, comma, positive infinity. The smallest y value on the graph is right here, and then every number bigger than it. Any questions on my logic?
It'll make a little more sense when you actually
have numbers rather than y value of vertex. Okay? If it's opening downward, we said that this thing is going to be a maximum. That's the maximum y value. That's the biggest y value on the graph. right here at this point. So the range, in this case, remember, interval notation has to go small to big. This thing is going down and down and never stops. So negative infinity, small, to the biggest y value is the y value of the core of the vertex. So y value of vertex. It's a lot to think about there, but once we see an example, it'll all make sense. It'll get better.
At least it won't get worse. Let's do number 9, trying to put all of this together, where there's actually a function, not just ax squared plus bx plus c. Let's do one where a, b, and c have numbers. Oops, no.
That's number 9.
Oh, okay.
Well, if you want to do a less painful one, we could do number 8.
No, let's do 9. I like these messy numbers.
Okay. Of course, you're just sitting there. You're not the one actually. Negative 4x squared minus 40x minus 96.
Not with the calculator.
I'm pretty sure we're going to want to have our calculator here. Okay, they want us to graph the quadratic function. We have to give the vertex, axis, domain, and range. So we're going to need the vertex, axis, domain, and range. And you know what I'm going to do?
Find the vertex.
I'm going to do something else right here. I'm going to write vertex and draw a line. Axis. So remember what we have to do. Domain and range. Okay, I'm going to see. Yes. Now, before we go on, before I do any work, I can fill in one of these blanks already. Which blank can I fill in? All quadratic functions have the same blank, because there's no square roots and no fractions. They all have the same. One of these things is the same. The domain, all real numbers. Good.
Which we write as negative infinity
to infinity. So now let's use our vertex formula to find the vertex. We'll do
when
that.
you do that, you'll also be finding the axis.
That's right. Because remember I said the vertex and the axis formula, you're using the same formula. X equals minus b over 2a. Look up here. What's b? Think of it as a quadratic formula. What would b be? A quadratic equation. Negative 40. So, and what's a? Negative 4. Watch out for all those negatives there. The opposite of negative 40 becomes a positive 40. What have we got in the denominator? Negative 8. 40 divided by negative 8 gives me a y value of negative 5. So there's my vertex. I mean, not my vertex, my axis. X equals negative 5. It's a vertical line. You can't just write negative 5. Negative 5 is a number. X equals makes it into a vertical line. Remember we said vertical lines have an X and no Y in their equation. Now to find the actual vertex, it's an ordered pair. That's an ordered pair. We're going to have to plug in the negative 5. So here's my table of values. Remember over here, as we're going through the discussion, I said you'll make a table of values, and you have to use the number that you got from negative b over 2a. And I said it'll make more sense when it's an actual number. There's the actual number. We're going to have to plug in negative 5. Plug negative 5 into the formula for x.
Lower it so I can see that. I'm going to use my calculator.
So we're plugging in negative 5. We have a negative 4 times a negative 5 squared minus 40 times negative 5 minus 96. That would be a positive 25 times a negative 4. That's a negative 100 plus 200. So that's a 100 minus 96. I'm getting a positive 4. Let's see if Tony's calculator gave me the same number, a positive 4.
Mm-hmm. That's the vertex.
So there's I'm going to write it right here.
And I'm going to go ahead and punch that answer in.
Negative 5, positive 4.
Make sure, if I would do this, negative 5, comma 4, what's it going to say? Your answer must be in the form of an ordered pair. Make sure you have enclosed your answer in parentheses. So parentheses and parentheses. Okay. Now it wants us to graph it. Okay, well, before we do that, we need another
ordered pair. Remember I said you'll have to plug in the minus b over 2a value you got. You've got to use that. And then you use another x value. What's my favorite number to plug in? What do I think's easiest? 0. If I plugged in 0, I'd get 0 minus 0 minus 96. Do you think that grid, pull up that grid, Tony, does it go down 96 units? I'm betting it doesn't. Looks to me like it only goes down 20 units.
20.
That's why we said whatever number you use, it needs to be close to that number there. I'd say 2 units away. Maybe use a negative 3 or a negative 7. But use something close to negative 5. What do y'all want to use?
Well, you could use a negative 6 and a negative 4 also. So, yeah, but okay. So,
how about a negative? What do y'all want to use? Something close to negative 5. Negative 6. Okay, here we go. Plugging in negative 6. Plugging in a negative 6. There and there. That's a 36 times a negative 4. That's a negative 144. Plus a 240 minus 96.
oh. Are y'all getting 0? I'm getting 0.
Yeah, I'm getting 0 too. 144 plus 96. That's 240 minus 240. I'm getting 0. Yes.
But this point here is you're choosing it.
I'm choosing that myself.
You choose the negative 6.
But make it something close to the minus b over 2a value you got.
If you chose something like 0, you figure out, okay, it's not going to work on the graph.
Okay,
right?
let's plot it.
Okay.
Okay.
Oh my gosh.
Okay.
But that doesn't make it any better.
Choose a tool in the palette and follow the instructions. Well, there's only one thing that looks like a parabola. If you come right here and hover around it, I guess there's one, but the horizontal thing, would it be a function? We're not graphing those, okay? This is a vertical parabola. You click it, and what does it say to plot first? First thing you plot is the vertex. Oh, wow. Negative 5, 4. Just be looking right up.
Oh.
Negative 5.
Oh. Okay. There's got to be a better way to make this bigger. Let me see. If I come over here.
Maybe, yeah. Let's just try it like, wait. Let's try it like this.
Oh, you got to.
You click it, okay, and then I go to the parabola tool, the vertical parabola tool. It doesn't matter whether it's opening up or down, you still use the vertical parabola tool. We click there, and it's what, -5. Oh, I can't see where it's saying the points. This is no good. Tony, that is no good. I'm going to come over here.
What if
I'm going to go, I'm going to click. I'm pretty good with this. -5, +4. -5. Oh, is that it? There's the vertex. Oh, it's not showing the instructions. Now you see, it's drawing every possible parabola that has a vertex at -5, +4. Well, it says choose one other point. Notice it's taking advantage of the symmetry. You choose the one other point, and it's going to draw it in. The other point is what? -6, 0.
You're good at this.
There it is. Is that it? -6, 0. You see where I'm looking? You see there in the yellow box it says where I'm located? -6, 0. I do that. I save it and send it back over here. And then I check my answer. Once again, y'all's grids won't be so, shouldn't look as bad as ours. Ours is messed up because the way we blow up the screen to make the problem writing bigger and
I
stuff.
should have moved this. That might make
Yeah, that's certainly you should do. No, that's just there. But then you got that calculator in the way.
Well, okay.
And now we're ready to write in the axis. It says type an equation. Well, we know the axis equation. It was, let's switch back over here. X equals, realize it has to be written as x equals, just like the vertex has to be written as an ordered pair. So x equals -5. Type it in, Tony.
X equals -5.
And now we're ready for the domain. We know that domain. Every quadratic function in the world has the same domain. All real numbers. Parentheses, -infinity, comma, +infinity.
I wonder if I wrote positive infinity.
We were discussing that. If you put the plus sign, do they count it?
Sure,
they should.
do. Yeah, they do.
Okay, good. And for the range, remember what we said over here. Let's see. Look back at my paper, Tony.
Okay. Pull up that crap.
Which situation do we have? Do we have a case A or a case B? The parabola that we graphed just now, is it a case A or a case B? Was it opening up or was it opening down?
It's opening
It's
down.
opening down,
Okay.
so switch back to the paper. Then we say the range, all the negative y value is going to be used up to a maximum of the y value of the vertex. So it's going to be from -infinity up to, what was the y value of the vertex? Come back to my paper.
Wait, I want to blow this up. Oh, well.
The y value of the vertex. You could just switch
There.
to my paper right here. It's
Okay.
from -infinity up to the y value of the vertex is 4. So from -infinity up to the y value of the vertex is 4. And we use a bracket after the 4 because 4 is used
It's a
as a
dot.
y value. It's we have a dot there for the vertex.
I remember once a student asked me, can we always say that the x value of the vertex is in the axis and the y value is in the range? Is that always true? And I said, yes, that's always true. But look at what he's saying. If you look at the graph, and I know it's sort of messy, what are the y values? The y values are from 4 And then it just keeps going, more and more negative, smaller, smaller.
But you can't say 4 to
comma.
negative infinity. It has to go small to big. That's why the negative infinity has to go first.
All the y values are 4 or larger. Or excuse me.
Smaller.
Smaller.
Just type in the answer.
4 or smaller?
Yes.
I can't type that in.
I meant negative infinity or positive 4.
Negative infinity, comma, 4, bracket. That means that the y value, you're saying that the x values can be any number. But y values.
Well, the biggest y value you'll ever get is 4. And then every number smaller than 4. Let's go back to number 8. Okay, here's another graphing one.
This one's not going to look so, there's not a minus 96 on it and stuff. The numbers are a little bit nicer. Hey, is this one going to be opening up or down?
Switch over to my paper. On this one, the A value was negative, and so when we graphed it, we saw it was opening downward. What's the A value here? I don't see a number in front of x squared. That's a positive 1, which means we expect this graph to open up. I agree. They have the same questions. They want the vertex, axis, domain, and range.
One of them we can fill in already.
One of those 3 blanks. Which one? Blank 1, 2, 3, or 4. 3 automatically, all real numbers, negative infinity to positive infinity. To determine the vertex and the axis, we use the formula x equals negative b over 2a What's b? 2. I agree. What's a? 1. I agree there as well. So we have a negative 2 divided by 2. A negative 2 divided by 2, which equals a negative 1. So we know the axis. The axis is x equals negative 1. Any questions there? Now, we have an ordered pair. We know the x value. What's the x coordinate going to be right here in the vertex? Negative 1. We have to make our table of values. We've got to plug in negative 1. Plugging in negative 1. Plus 2. Let me push this up. We're plugging in negative 1 there and there. We're plugging in negative 1 in place of each x. Negative 1 squared is a 1. Minus 2. 1 minus 2 gives me a. Negative 2 minus 8 gives me a negative.
Negative 1.
No.
1 minus 2 is negative 1 minus 8.
Oh, what was I saying? Why didn't you correct me?
I did.
1 minus 2 is a negative 1. Minus 8 is a minus 9. God. Oh.
Now, any number close to negative 1.
What do you think I'm going to use? I like to use 0. 0 is so easy to plug in because those numbers right there, those terms automatically become 0. and you're left with just the constant.
Oh, wait, let's fill in your little blank here.
Oh, I got to fill that in.
So I'm going to start with typing in the answers. First, the vertex. Gotta do it in those parentheses.
-1, -9.
-1.
It's not writing. You're typing
Oh, I'm
it in your
typing on my
calculator.
calculator, yeah. -1, -9, close parentheses.
Have y'all been able, there was a website that where we were able to download that little virtual calculator years ago, and then TI forced them to take it down, okay? And so
We have the software.
I have the program. Anyone that wants it, just bring a flash drive. And
Can't
I'll,
use it on a test, though. The software won't let you open it up.
You're right.
I know.
Oh.
Okay, so
We click the parabola, the vertical parabola tool, and the first thing you have to plot is the vertex. That's -1, -9.
even this.
You're going up. Wait.
Oh, wait, -1, -9.
-1, -9. Click. And now we want one other point. But look at that. As I move my mouse around, it's drawing every possible parabola in the world that has a vertex at -1, -9.
Wow.
That's what it's doing. Thinking back as a student in the 80s, this would have just been science fiction, okay? So, anyway, what's the next one? What's the next point we want? 0, -8. 0. I'm going further. I'm getting
There's got to
worse.
be a better
There.
way to
0, -8. Is that it? Transfer. Of course there is. We shrink this writing down so this grid appears completely visible, and then check our answer. It's not through. Don't you just love these problems with one part after another after another?
What am I going to type for axis? X equals
-1.
-4. Domain. I know that. Parentheses. Infinity. Close parentheses. Check. Okay, now the range takes some.
Oh, you have the graph. Don't change anything, okay? Except switch over to my paper. Okay, for this parabola, what do we have? Case 1 or case 2? Okay. The vertex is corresponding to a minimum. That's the smallest y value. That means it's going to go first in the ordered pair notation. The graph keeps going up forever, so it keeps going up to positive infinity. So the smallest y value is the y value of the vertex. And the y value of the vertex, what was the y value of the vertex? -9, so it'd be -9 to infinity. So I'm going to write right here, -9, infinity. Any questions with our logic there?
It's a blank.
-9,
Infinity. Close parentheses.
Now some word problems, and as we said earlier, they're all asking for maximum or minimum values.
Hey, let's do
And
number
remember, maximum and minimum values must occur at the vertex. Oh yeah.
10. Look
Okay,
at
I
this
like
one.
this.
Okay, let's see. Can I make it bigger? See, this parabola is opening up, and so the vertex, would y'all call that a maximum or minimum? It's a minimum. It's asking you to find the minimum value of f of x.
F of x is just a fancy way of saying what letter? For an ordered pair, f of x is another way of saying what letter? Y. So what's the y value at the vertex? What's the smallest y value on that graph? 9. There's no y value that's smaller than 9. The minimum value of the function is 9. The minimum value of a function is the y coordinate of the vertex, not the x coordinate. And I think that's the point they're trying to make.
Now, number 11.
A woman is a taco stand. She found that her daily costs are approximated by c of x equals x squared minus 20x plus 660, where c of x is the cost in dollars to sell x units of tacos. Find the number of units of tacos she should sell to minimize her costs. What is the minimum cost? I've got to write down some. I'm going to have to write down a little bit here. Okay, this is number 11. In finite math, our business math class, we call this thing a cost function. It's a function that approximates her costs. And let's make sure we understand what costs are. This lady's costs are that's the money that she spends to open that stand, make her tacos, and have the business. That's what we mean by cost. She has to pay rent on that taco stand. She has to pay her utilities, what have you. That's what she's trying to minimize. She wants to have the lowest cost possible. So, switch over to my paper.
So, enough of the tacos. At this point, it's just an algebra problem.
They don't ask us to draw the graph of this thing. But if we did, we'd recognize that it's quadratic, so it's going to be a parabola.
Up or down?
Is it going to be opening upward or downward? Which one would it be if we were to draw the graph? We're not going to, but what do we look at to decide whether it's going to open up or down? Okay, remember we said if the leading coefficient, if the number in front of x squared is positive, it's opening upward. That number right there, I don't see one, so I assume it's a positive 1, so it's going to open upward. If it's opening upward, what does it have, a maximum or a minimum? A minimum, and where does that minimum occur? At the vertex. The minimum occurs at the vertex. Is that what they're asking us to find, the minimum?
Yes.
Yes.
But would it make sense for her to find the maximum?
Because it could just keep going up and up forever. So, if we're looking for the minimum, it has to occur at the vertex. So we use that vertex/axis formula. What's B? Negative 20. What's A? A positive 1. Watch out for those double negatives. What's that going to give us? Positive 20 over 2, which reduces to 10. Is that $10? Is that saying her cost?
Let's see, what is X? X is the number of units of tacos.
So that's not her cost. That's how many tacos she should make in order to minimize her costs.
Well,
so this is 10 units of tacos.
We don't know what a unit is.
Probably a dozen. What do you think?
It might just be an order of 3, or it might just be one taco. But probably not. Because they're the most expensive tacos in town. Because it now asks, what is that minimum cost?
So the first answer we knew by using the vertex formula. Now we want to know the value of the function. The value of the function, that's the y coordinate. We know the x coordinate. How do we find the y coordinate? Plug it in. So plug in 10 units. The cost for making 10 units of tacos we're plugging in 10. So that's going to be 100 minus 200. That's a negative 100 plus 660. That means 500. I'm getting her costs are $560.
That's why I'm thinking it's not. unit of taco is one taco. If she's spending $560 to make her 10 tacos,
then she's in trouble.
Yeah.
She'd have to sell each taco for $56 just to cover her expenses. So I think a unit, it may be a gross, it may be 144 tacos. Just depends
even
on how
if
big it is.
Well, that'd be some pretty serious.
I think a
tacos.
I think a unit is 100 tacos. I hope.
Okay.
But anyway.
So her minimum cost is
$560. If she produces anything other than 10 tacos, it's going to cost her her costs are going to be even higher.
So for these word problems, you're given a function. If you just do minus b over 2a and plug it in, that'll get you the answer. Sometimes students skip the word problems no matter what. Well, these, don't do that. Don't skip them. Okay. Oh, this one's a little tricky because of the way the function is written.
The number of mosquitoes, M of x in millions, in a certain area depends on the June rainfall, x in inches. The function that models that phenomenon is M of x is equal to 16x minus x squared. Find the amount of rainfall that will maximize the number of mosquitoes. And what is that maximum number of mosquitoes? Here's my question, and be careful. Will the parabola be opening upward? Is it going to open upward or downward? Okay, remember we said if A is positive, it opens up. If A is negative, it opens downward. Well, wait a minute, 16 is positive, but you're saying downward. What's the A value?
A isn't 16, is it?
A is -1. It might be helpful to write that down. A is the number in front of x squared. It's not just the first number. In this case, 16 is the B value. Remember, A is the number in front of x squared. The number in front of x is the B value. Oops. So let's use our vertex formula. And you said B was 16 and A was a -1. So what is that? A -16 over a -2. What's that going to give us? Negative, I think it's going to be a positive A. Remember, this is, what is X representing?
The inches of rainfall.
Go back to the
application problems, usually you don't want negative answers. Okay? How many inches of rain?
So there's 8 inches of rain. That'll maximize the number of
if you
mosquitoes.
Get more than 8 inches,
it drowns them.
Yeah, too much. Less than 8 inches.
There's not enough water for the mosquitoes to breathe. I made that up about too much rain drowns the mosquitoes. I don't know. I always thought the more rain you had, the more mosquitoes you had. But according to this algebra problem, that may not be the case. How do we find the number of mosquitoes?
What am I going to do with this 8?
Switch over to my paper.
Get in.
Switch over to my paper. So we found the x coordinate of the vertex. Now we need the y coordinate. The number of mosquitoes when there's 8 inches of rain. 16 times 8 minus 8 squared. Is that a 128 minus 64? I'm getting 64 million mosquitoes.
So if there's 8 inches of rain, then there'll be 64 million mosquitoes. Based on this formula, will there ever be a time when there's, say, 100 million mosquitoes? No. They can't get enough rain to get 100 million. The most they'll ever get is 64 million. This is a strange problem, I have to say.
Yeah.
64 million mosquitoes.
Any questions on our logic there? Number 13. If an object is projected upward from ground level with an initial velocity of 32 feet per second, then its height in feet after t seconds is given by...
Oh, look, it's not using X's or F's. They're using S's and T's. And that's standard in physics problems. It's
T for time. If an object is projected upward from ground level with an initial velocity of 32 feet per second, then its height in feet after t seconds is given by S of t equals negative 16t squared plus 32t. Find the number of seconds it will take to reach its maximum height. What is the maximum height?
Going up in the air and coming down.
Hey, wait a minute, switch over.
Oh.
They don't ask us to draw this, but if they did, if we did draw it, what would it be? Would it be case 1 or case 2? Case 2, that A value is negative, so it's opening down.
I was just thinking they could think their way through. I'm throwing something up in the air. It's going to go, is it going to be a parabola opening down or opening up?
So,
Write out your A value and B.
yes. What's my A value? Negative 16. My B value is positive 32. So it's not X equals. It's going to be T equals. So we have a minus 32. There's a negative 16. Negative B over 2A. What's that going to reduce to? Negative 32 divided by negative 32, that's 1, isn't it? So this is going to be a very short trip. It goes up for 1 second, and then what does it do? Fall back down.
But go ahead and find the height. How will we figure out how high it goes?
We use the vertex formula to find the first coordinate. To find the value of the function, you plug in that number, S of 1. Plugging in 1, one squared is 1 times negative 16 is negative 16 plus 32 times 1 is 32. Negative 16 plus 32. This object goes up 16 feet in the air.
So it's not going up real high. Right? It's a little toy rocket. Shoots
But
up.
It goes up and down pretty fast.
Yeah.
It reaches its maximum height after only 1 second. The object will take 1 second to reach its maximum height. And what is that maximum height? 16 feet.
It's not going up real high. And at that point, number 14 is a review. Find the domain, so forth.
Okay, so
What's the one number X can't be here? We can't have a 0 in the bottom of a fraction, so what's the one number X can't be? 0. And in the olden days, you would say the domain is all real numbers except 0. Y'all remember how to do that with interval notation? It's negative infinity, comma 0, close parentheses, union, parentheses, 0, comma, infinity.
Mm-hmm.
Everything to the left is 0, not including 0. Everything to the right is 0, not including 0. It's a fancy way of saying all real numbers except 0. So that's that for, and number 15 I think is another domain problem. But that's it for domains and ranges. Excuse me, piecewise and quadratic functions. Is there anything you need to say, Tim?
I can't think of anything, no.
Any questions? Okay.
Okay. I'm going to upload this video right now.
Oh,
If you have questions,
if you've got behind and you want to jump right into this assignment, we now know how to remove a prerequisite for an individual. So you need to just jump into this, and we're going to go back and catch up later. Fine. Just let us know. We can remove the prerequisite so you can jump into this assignment.
while you remember this stuff. Because you don't have to have graph circles to be able to do this stuff. Okay, so...
Yeah. We're working still on circles. We can remove those prerequisites and you can move on. Okay? I'm just so
Oh, you're still...